Welcome back. Tomorrow we will be doing a review. This is fucking beep thing. This is 15.8. We're finishing up Stokes' theorem. I've set it up. So for those of you not listening to Discord, I've set it up to our final will have 4 questions on it. I can test you on everything I think you need to know. One will be Green's theorem, one will be divergence theorem, one will be Stokes' theorem, and the 4th topic is conservative vector fields. I can pretty much test you on everything in Calculus 3 with those 4 questions. So I don't know that we need 2 days for the test, and I thought we would put it up for like a group opinion, whether we do it Monday or Wednesday. There are perks to both. Monday, you have it done sooner and focus on physics. However, if we do it on Wednesday and you need more, like we're covering Stokes right now, if you need more time to get caught up, Wednesday might be the better day because you still have plenty of time before your finals the following week. So think about it for a little bit. Let's get through this example and then I'll have Brandon do a poll in there and I'll ask people online. We'll bring it back up. Just think about whether or not you want Monday or Wednesday for the test. I will definitely be there early by 7 a.m. We're doing Monday or Wednesday because it allows me to stay till 9:30. And so you'll have plenty of time to do 4 questions. I've made sure the questions have
multiple parts,
less of the complicated shit in Calc 1, like integration by parts. It just takes too long. People fuck that up too much. But just think about it, Monday or Wednesday. Let's get cracking on some examples. This is what we're working on here, and we're doing Stokes' theorem today. So it's we're doing the line integral. So the line is going, the curve is going like this. And it's following around those dots. So one of the vertices is 2, 0, 0, and on the x-axis, we've got the origin, and then we've got 0, 2, 1, which is in the zy plane. Give you some time to write it down, then we'll discuss what surface we should use and go from there.
My first shower. I feel like I can take a shower right after. Because I feel dirty stepping out of the shower.
Where do you live? Florida?
Broke scanner. The water's still yummy.
It's absolutely
All right,
fine.
so presumably you got that written down. Let's take a look at doing the curl of F, and then we'll decide on what surface we're going to go with from there. I don't know if you guys fill in the matrix upside down like I do, doing the bottom row first. Usually the bottom row is the one that takes up the most space. And if I do IJK across the top first, I never have it lined up well. So I do the bottom row first and fill upwards. So we do the curl. We've got, I'll set it up the way you guys like, doing the I and the J afterwards. Right now, we're just setting up our parentheses. So ddy of 6x is 0 minus ddz of 4z is 4, 0 minus 4. And let's see. Then we're going j, ddx of 6x is 6 minus ddz of negative 3y squared is 0. And then we get to our k hat. And ddx of 0 or 4z is 0 minus ddy of negative 3y squared is minus a negative will be plus 6y. So I have negative 4, negative 6, 6y. So that's my curl of f. Now the surface we want to work with, it needs to be a surface. I don't want it in 2 dimensions or 3 dimensions. So we should map this curve to something that has the same thing. And if we switch ds to dA, maybe by mapping it downward, if like we move it down to the XY plane, then we've got 2, 0 here is the XY plane. Along the Z, this dot right here is at y equals 2, right?
I see.
Because y equals 2 here, I'm just bringing it straight down. So this blue line right here maps to going that direction right there. If I project it down onto the XY plane. Which is convenient because n for the XY plane is 0, 0, 1. So what would the limits here be if we do that projection? Since if we do the curl, let's just see what curl of f dot n looks like with those things. We're going to have negative 4, negative 6, 6y dotted with 0, 0, 1. The integrand is going to be just 6y. That's going to be what's on the inside of the integral. So now we need to figure out how we want to do dA. So this is the y equals, what is this? Y equals negative x plus 2 line, or 2 minus x. We could do dy first and go from 0 to 2 minus x, and then do x goes from 0 to 2. And then we've got 6y dy dx. Alternatively, we could do x first. So there is more than one way to do this, of course. So, I agree. We got 0 to 2. 6y integrated will be y squared divided by 2, so 3y squared. Evaluated from 0 to 2 minus x dx. So what we have 3. That is going to be 2 minus x times 2 minus x for our y squared. So that is 2 times 2 is 4. Then I've got minus 2x is minus 4x. And then minus x times minus x is plus x squared dx. All right, I'm going to leave the 3 outside and just integrate so I don't need to write another line. We've got 4x minus x goes up to x squared divided by 2. We got 2x squared. And then x squared goes to x cubed divided by 3. And we're going from 0 to 2. The 0 part's fairly easy, so we've got 3 times 8 minus 8 plus 1/3 times 8. That goes to 0. And then the 3 times the 1/3 cancel out. This just ends up being 8.
The triangle project down as an XY plane up. Yes. We assume it's always point up, projected down. If we project it like to the XY plane, yeah. So it's just the only component is the component at that point. Okay, and then if you project it on the Z plane or something, yeah, Z plane, then it will be the X depending which one it's facing. Oh, okay. Or no, yeah, so even if it has a negative value. Okay. Yeah, that's which plane you're in. Okay. Okay. At least that's what I think.
That's not right. I wasn't supposed to project it down. I did the wrong thing here. Shit.
Wait, what happened?
No, you were supposed to do that.
I wasn't supposed to project down. This was a simple plane already. All we had to do was use the plane. So this did not. You're gonna get mad, but I'm gonna erase it because that is not N. Let's go back. There's a mistake. I made a mistake. Because we have the surface here. I wrote it up there. Z equals 1/2 y. Z equals 1/2 y. So I can do N as the gradient of G, which is the negative ZX, negative ZY, and 1. I don't know why I got projection in my head. That was bad.
Right.
And if we do that, the gradient of G is 0. We've got negative 1/2 and 1.
What is it?
And what I was missing, we just used 001. We were missing that component.
The end just.
Because we're going off of z equals 1/2 y. That's the plane that we're in. So the normal vector is easy to use. And what I did actually changed it to being a different plane. It still gives us the right limits of integration though. So 0 is going to 2, or x is going from 0 to 2. And y is still going from 0 to 2 minus x. But now we're dotting it with 0, -1/2, and 1. And we're going to get 3 plus 6y. So I'm going to pause, let that sink in. I get so used to doing projections with the divergence stuff, and you guys will have the same issue too. When you have the curve, you got to make sure you keep the points of the curve, and I didn't. By projecting onto the XY plane, I was no longer along the curve. And we're doing a line integral. So like if I'm not on the curve, what am I doing? That had to stay consistent. So we do this here. We've got 0 to 2 and 0 to 2 minus x, 3 plus 6y dy dx. I'm sorry about that.
All right, make that on file.
So we integrate. I'm still going to do that x minus or 2 minus x over here. Fill that in a little bit easier. I'm going to factor that 3 out. So this y goes to 2 minus x. And this other one is plus 4 minus 4x plus x squared. And I will clean that up before I integrate it because I don't want a whole bunch of shit. 2 plus 4 is 6. I've got minus 5x plus x squared. Six x minus 5 halves x squared plus 1/3 x cubed. Evaluated from 0 to 2. So 3 times 2 plus 8/3 is going to be 6 plus 8 equals 14.
The vertices? What are you using at all?
It represents the triangle of the graph itself. So that graph of the triangle that gives up there, that's what those vertices are.
Did you use it and comment?
Yeah. Use hey, Mr. Jones, could you scroll up? Or sorry, move the whiteboard up a little bit.
I don't know how much.
Yeah, because Eric was asking about the vertices that didn't seem to be used, because you use them to create that triangle that you have graphed, right?
Yeah, but the z equals 1/2 y is a very big plane. The vertices were used to give us our limits of integration.
So
So-
basically,
The mapping I did, let me pull up another, because I think this will help and it'll show why I fucked up earlier. So I'll bring this back in a second if you guys need that up longer, but let's go over what I was doing. We had it like this. And it's making this triangle right here, where that is y equals 2, this is x equals 2, that's the origin, and this is the z equals 1/2 y plane. Or negative 1/2 y plus z equals 0 plane. Now, we need to stay along the curve. We have to stay along the curve because but the reason why it's helpful to look at it mapped onto the XY plane, when I map it onto the XY plane, gives me the integration limits. Is like looking from overhead. So like if I look from overhead and I try to, I want to keep it the same way, that would be Y and that would be X. This looks funny to me, but I'm going to do it because it's like me looking down the X, like looking down the Z axis. And it's easier to see that this point right here maps to right here. And this point right there maps to right here. So that curve has got this line segment connects those two dots. So this is a overhead look down.
it's also possible that you might not be given the z itself, and you have to use the vertices to find that plane. If you get help like that.
So those were the vertices, and we're looking down. This gives us our limits of integration. This line right here is y equals 2 minus x. That is y equals 2 minus x. It might be helpful because see, to me, this is hard to read. So if you rotate it to look like the y-x plane correctly, the way we're used to seeing it, you'll see it looking like that. And now that's a little bit easier to see that that is y-intercept of 2 with a slope of -1. So all I did is just spun it. But we're not using n off of this plane. This is just to get the limits of integration. N was given to us by the plane. So we can get n from here. And the coefficients there are 0, -1, half, and 1. And I think when we do the next problem, I think we'll do the same thing and discuss this a little bit better there. Part of the reason I think Wednesday might be a better day is we can clear up any last minute shit on Monday and Tuesday, any misconceptions people have after we do the review tomorrow. I'll send out the review this afternoon.
Wait, so you're for sure only having 4
We
questions.
only need one day. It's 4 questions.
4 questions. Yeah, it's 30% of our grade. Yeah, that's what mine. Yes, Wednesday. 10%, damn near 10% on every single question. I don't know.
To be honest, I think I could raise people's grades if we spend Monday and Tuesday reviewing some of this stuff and reviewing some basic fucking integrals. Like, because that's where a lot of you guys are losing points. You're doing your Calc 1 shit wrong.
Maybe even Starbucks Monday and Tuesday night.
Yeah. I can do Starbucks on Monday and Tuesday night.
So great.
All right, so let's take a look at the next problem.
We can move on with our lives.
Does anyone need this part up longer?
No, we're good.
Okay.
If we do the test on Monday, do you think you'll have it graded by Wednesday?
We will be done by Tuesday.
I plan on grading it ASAP regardless which day it is. Because I have 3 stats classes to grade after that. And I don't want to, I'd rather get your guys' shit graded before finals week starts for the other students.
I see.
So you will know your final grade regardless. If we do it on Monday, you should have it by Wednesday. If we do it on Wednesday, you should have it by Thursday. You know, it's not like. So actually, before we start this, you guys can write down this problem. Let's do a little like quick vote on what people want. And people on Zoom, if you want to put it in chat, your answer, which day you want, I'll tally it there as well. Brandon, can you count the? What?
I have a poll on the board.
Hey, Brandon, kick everyone out the Zoom real quick.
All right, so who wants Monday for the test?
4.
Who wants Wednesday?
1, 2, 3, 4, 5, 6, 7, 8.
I think you're getting your ass kicked, Eric.
Now, I also have a third option I have on the board. There, I'm gonna ask who wants it to have it never.
Yeah,
Does that mean we get a
that
0?
means you get 0% on the final and no one passes the class. Well, no, some people will pass with a C. Those that got A pluses the rest of on all the tests. Not having a final is out. So everyone on Zoom is saying Wednesday as well. It looks like we'll do the test on Wednesday. And I think a couple days of review on Monday and Tuesday would work. Going over some shit that some of you are excellent at and won't need to review and can spend time focusing more on other shit but like Monday and Tuesday, we'll hit like some Calc 1 topics, your basic integration stuff that people are fucking up. Product rule, chain rule. I think that's the best way I can help you as your math instructor at this point. So we'll do it on Wednesday, and I'll send out an announcement. And I'll edit the online shit to reflect that.
We're doing Wednesday.
Like democracy here.
So this is the problem. And that is the letter C. So the curve is the intersection.
All you gotta do to fix it is just become the person in power instead.
Not attached to that, attached to this. Then the class is gonna decide, I'm still gonna, right?
There's always someone above you. Doesn't matter, doesn't matter even if you're the president of the United States.
And.
So what do you guys want to start with? The curl of F or the picture finding the curve?
That's like the hardest part.
I'm hearing a lot of votes for pictures.
Pictures, all right. So the cone is like, if I treat this, if I square both sides, this is z squared equals x squared plus y squared. So in 3D, let me do this a little bit differently, because I can see z has got to be positive, so I don't need a negative z axis.
But I don't know.
When x is 0, we're just looking at z in the y plane. We have z squared equals y squared, which makes a, let me do a different color.
Find out, I guess.
So the cone is doing this. It's got that. And that's like z equals y and z equals negative y. If we do it for when we do y equals 0, we're going to have the same thing for z equals x and z equals negative x. This looks like it's making a nice little cone like that. So our sphere is going to overlap that, and at some point it's going to hit like that. God, that's terrible looking. That's a little better. So we're looking, and what we're looking for is this curve of intersection, which is going to be this ring. So we're going around the curve like that. And it's where the two graphs touch. And the easiest way to see where the two graphs touch is to set them equal to each other. And rather than doing where, like I've got this in terms of z, I could write this in terms of z, or I could just use this z squared part. So maybe I'll use the z squared part. And so this z squared, I could actually do direct substitution, but for those of you that aren't comfortable with that, this written as, that's my blue line, so let me use blue. This z squared is 1 minus x squared minus y squared. And this z squared is x squared plus y squared equals that one. So since they're both equal to z squared, we can set them equal to each other. And that's where we get this curve. I'll add this negative x squared and y squared to the other side, and we've got 1 equals 2x squared plus 2y squared. And they have the same coefficient, so if I divide by 2 and I just change the size where everything is, I've got x squared plus y squared equals 1/2, which is a circle of radius 1/√2.
So is that top circle that we're traveling? Oh, yeah.
That's the curve we're traveling along. This is actually flat in the xy plane. So our normal vector should be straight up. Yeah, the Z is going to be an equal height going around the cone for that. So Z is constant around this circle. In fact, x squared plus y squared equals 1/2, which equals Z squared. That is our Z's. This is the plane Z equals 1/√2. For our green curve. So rather than just going, it looks like it's flat, we can actually see that this is just being, since these are both Z squared equals 1/√2, that is the Z equals 1/√2 plane. Now we need to do the curl. And it's a long Z plus sine X.
It's just funny as it is.
That circle's a little lopsided, but fuck it. I'm not rewriting it. So doing I d dy of this is 1 minus d dz of that is 0. And then we do our j d dx is 0 minus d dz of that is 1. And then our k component is 1 minus 0. This is the 1, 1, 1. That's all that's left when we do the curl of f. And n equals 0, 0, 1. So the curl of f dot n
Of just that. Okay, we can just tell by just where they are, where the guys stand. So scopes is defining work and the directions to define flow.
So we are down to doing our surface integral of 1 ds. So there's two ways of going about this. The cheap method we'll do first because it kind of will help support the idea for the other one. The surface here is a circle of radius 1/2. So the surface area of a circle of radius 1/2, or 1/√2, sorry, is pi times pi r squared. 1/√2 squared is just 1/2 pi. So we know what the answer is going to be here because we're doing 1 times the ds. So 1/2 pi. I think what might help you more as students, though, is looking at
So wait, so
if it's not always that, because this was a simple area, but Matt, let's look down the z-axis. If I look down the z-axis, I'll put it the way it initially looks with y like that and x like that. If I just look straight down, I've got a circle like this. with x squared plus y squared equals 1/2. Now I could do dx and dy, or I can switch to r and theta here. And if I do r is 0 is less than r, less than 1/√2. And theta is less than 0, or 0 to 2 pi, sorry. That's that surface. And it's the same thing up here. We've already done the normal and stuff already. So we could just do this as 0 to 2 pi, 0 to 1/√2. And then I've got my 1. And then in polar coordinates, we've got r dr d theta. So separating it, we've got 0 to 2 pi d theta, 0 to 1/√2 r dr. So we've got the first part is 2 pi. And then this is going to be 1/2 r squared evaluated from 0 to 1/√2. So I'm going to have 1/2 times 1/2. R squared being the 1/2, this 1/2, and then this 1/2 being that 1/2. And when we clean that up, we will get that pi over 2 or 1/2 pi that we see over there. This is definitely just going, oh, it's a circle and it's the area function. And since the integrand is 1, we can jump straight to the area of a circle. You can't always do that. So the walking through the path is a better choice. This was a shortcut based on the situation.
So if this answer is supposed to like describe the work done by going around that loop, how does that
Yes.
area give us the same thing?
That, yeah, it's giving us the work.
You did answer his question.
The area of the circle itself is how much work it takes to go around the circle.
Lawrence is asking like why the area in this type of situation, why the area of the circle was also.
I think Lawrence, to better answer your question, it's unique to this problem. If this was like X or Y or something besides 1, it's not just the area of the circle and we cannot do the shortcut. And then it's based on the values of it. In this circumstance, however, it just amounts to 1. If this was like X squared, Y squared in there, or X squared, Y, if we had this, we're not shortcutting. We cannot do this shortcut because the area of the circle is this entire integrand thing is dependent on X and Y. So there's no shortcut. Since this was just a constant value 1, we can shortcut it. But normally it's not just the area of the circle. I think that helps answer your question a little bit better. Because you're like, why is the work just the simple circle? And it's only that way in this problem. Or any problem that gets you a 1 when you do the curl of f dot n. Alternatively, we know the curve. We can do f dot dr. And you should still get the same thing, pi over 2. We just need to map r at that point, and that's more work. if I were to map R, I've got 5 minutes. Let's just talk about it. If we were to do f.dr on this problem, this circle, if I were going to map it, it's a circle of radius 1/√2. So I could say R of t is, the x component would be 1/√2 cosine t. The y component is 1/√2 sine t. And the z component is not changing. It's just 1/√2. So I can factor that 1/√2 out. And I'm going to do that before I take the derivative, just to make it shorter.
This is a R translation. It's not putting that R will probably be put in, or the F will use that R, but R doesn't get interaction for the F.
We're going to have to plug in stuff for this stuff in there to do it. But it would get ugly. dr dt is 1/√2. We've got negative sine t, cosine t, and 0. F is ugly as hell though, because that's my x, that's my y, and that's my z. So to do the f, we need f evaluated in R. And that's going to be, the z is 1/√2. Then I've got sine of x, but x is 1/√2 cosine of t, which means that's going to take a little bit of work thinking out first. Sine of the cosine. Then we've got x plus y squared is 1/√2 cosine t plus 1/2 sine squared t. And then my z component is y, which is 1/√2 sine t plus e to the z is plus e to the 1/√2. This is not something it looks like I want to work with. In particular, that is meh. So we could do it. But does that even look like fun? No, it don't look like fun to me.
The last part.
Yeah, please make sure it's action to this test.
If it just need weird water on it, if not, then floods the whole house.
So we'll do a review on this tomorrow. I'll have a review exam for you up shortly. And we'll cover it tomorrow. Monday and Tuesday, we will go over any loose ends. Like if you guys are working on the homework on Stokes and divergence and you've got questions, we'll hit on it then. We'll also do some review on some basic integration so you don't make stupid mistakes that you should already know. And we'll do the test on Wednesday. What, Lawrence? No.
Asking you about extra credit question on the last.
The extra credit is showing me your homework. So if you've been doing it on PDF, you can always send it to me.
I'll be holding my regular SI hours today as well.
I'll talk to you guys tomorrow.
Yeah.